Alright guys, so we're gonna solve number 4 from the exam review. This is the only problem that was requested for me to do, so that is what we will do, and any other problems we can cover tomorrow in class. So number 4, it says, a container has the shape of an open right circular cone as shown. The height of the container is 10 centimeters and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth, h, is changing at a constant rate of -3 over 10 centimeters per hour. And then it gives the volume formula for the right circular cone. So part A says find the volume of water in the container when h equals 5, indicate the units of measure. Okay, so we're going to start with A, and it's just asking to find the volume of the water when h is equal to 5. So we're going to write down our formula, 1/3 pi r squared h. And remember, what I like to do is go through and know what I have and what I don't have before I start the problem. So I want to find the volume, so I don't know that. I don't know what the radius is, but I do know that the height is 5. So a question here is, how do we know what the radius is? And as I've taught you previously, whenever you're doing these types of problems, you need to draw similar triangles. So anytime you have a cone related rates problem, you need to draw similar triangles. And here's what I'm talking about. So I gave like half of the cross section of the right circular cone. The entire height is 10 centimeters. And since this is only half of the cross section, the radius is 5. Because if the diameter is 10, the radius has to be 5. Okay? So that's going to be the biggest triangle. The smaller triangle is going to have a radius of r and a height of h. So remember, for similar triangles, we need to do ratios of corresponding sides. So I'm going to do the radii first. So I'm going to do 5 over r is equal to 10 over h. Now remember, I'm looking to solve for r here, okay? So I know that when I cross multiply, I get 5h is equal to 10r. Divide both sides by 10, and I get that r is equal to 5 over 10h, which leads me to 1/2 h. Okay, so if h is equal to 5 centimeters, then r is half of that, which is 5 over 2. Okay, now I'm going to put all of these in fractions, since that is how the solutions were written, with fractions, reduced fractions, and all that stuff. On the exam, if they give it to you in decimals, you can make it 2.5. Okay, so now I know the r, and I'm ready to go, because all I want is the volume of water in the container when h is equal to 5. Indicate the units of measure. So the volume is equal to, I'm going to make this 1/3 pi just be pi over 3. That makes it easier to look at. The r is 5/2. We're going to square that times the height, which is 5. And then we get pi over 3 times 5 squared is 25, 2 squared is 4, and then we're going to multiply that by 5. So up top, we're going to have 5 times 25 times pi, which is going to be 25 times 5, 125 pi up top, all over 4 times 3, which is 12. And then what you can do, because this is the calculator section, is see if 125 divided by 12 reduces. And we find that it doesn't. They don't have any factors in common. So the volume is equal to 125 pi over 12. Indicate the units of measure. We're working in centimeters here, so volume is a cubed unit, so we're going to do centimeters cubed. All right, so that gives us part A. Part B is when we actually get into the calculus, and it says find the rate of change. That should be a big indicator of what you need to do here. Find the rate of change of the volume of the water with respect to time when h is equal to 5. Okay, so I want dv dt, the rate of change of the volume with respect to time when h is equal to 5. Which means I'm obviously going to need to take the derivative, the time derivative of this formula. So let's do it up here. I'm going to do dv dt is equal to pi over 3 is a constant. We're going to multiply that times the derivative of r squared h. Now you notice that r squared times h, that's a product, so I need to use the product rule, which is first, so the r squared, times the derivative of the second, plus the second, which is h, times the derivative of the first. So the derivative of r squared is 2r times dr dt. Okay, sorry about that. So what we're going to do is just kind of clean this up a little bit. You have pi over 3 times r squared dh dt plus 2rh dr dt. All right, well, when h is equal to 5, I know that r is 2.5. I know dh dt, because it's given to me in the problem, is negative 3 over 10. And so I know that. I know r, I know h. I don't know dr dt. So that's problematic because I need dv dt, but I don't know what dr dt is. So this is where the right triangles, or sorry, the similar triangles come in handy, because I have an expression for r in terms of h, which means I could differentiate both sides with respect to time, and I get that dr dt is equal to half dh dt. Okay, and therefore what I know is since dh dt is equal to negative 3 over 10, then I know that dr dt is equal to negative 3 over 20. So now I do know that. All right, so let's bring it all down here. All right, and now it's just a, plug and chug. So r squared is 5 halves. That's from the previous problem. dh dt is negative 3 over 10. 2 times r, which is 5 halves, times h, which is 5, times dr dt, which is negative 3/20ths. All right, so now it's just a numbers game. So pi over 3, 5 squared is 25. 25 times negative 3 is negative 75. And then 2 squared is 4. And 4 times 10 is 40. All right, plus, actually it's going to be minus because you see that negative 3. So I'm going to just go ahead and erase that now. And then I'm going to subtract. So 5 times 5 is 25. 25 times 2 is 50. 50 times negative 3 is negative 150. And then if I look at the bottoms, I get 2 times 20, which is 40. All right, so I have, I can do the brackets. Negative 75 minus 150. Don't rely on your mental math. Actually do it on a calculator, okay? So we get negative 225 pi over 120, because 3 times 40 is 120. Let's see if that reduces. It looks like it might, and it does. It reduces to negative 15 pi over 8. Now we just have to look at the units. It's a rate of change of volume, so it's going to be centimeters cubed. And the time, you have to look at the dHdt, the time is hours, so it's going to be negative 15 pi over 8 centimeters cubed per hour. And there is our final answer for part B. And there was our final answer for part A in number 4.